Just kidding. Okay, share screen again. Let's do that, share that. Okay, sorry. Anyway, so this is clearly inequality notation, and that's one way that's been used historically by a lot of mathematicians. But then other people, for very good reason, invented a kind of a graphical, because graphs are by design a picture, and yeah, the picture's worth 1,000 words. It's really, really nice. And I don't know if you guys have all done that in other classes. A lot of teachers always start with 0 on the number line. I never start with 0, because 0 may not even be anywhere near the conversation we're having. If you're talking about the national debt of the United States, 0 is like 16 pages to the left of anywhere you'd start. I mean, when we're in trillions, 0 is not even a relevant value. So I'm going to find the number 2 and 7, which are pretty easy to find because they're wherever the heck I want them to be, because it's just a visual. Now, can anybody tell me what I should do then? How do I communicate that I want all of these values? Okay, so let me ask you a question. What's a number that satisfies it? That is simultaneously bigger than 2, less than or equal to 7? 3, sure. What else? Okay, let's come up with a more interesting answer. Not 3, not 4, not 5, not 6. Let's be even more interesting than 5.5. 4.20. 4.20. Let's go even further. Is pi in there? Is the square root of 19 in that list? Is 2 pi in the list? Now look carefully. Is 3 pi in the list? So one of the things that I want you to get used to is our class lives in what's called the real number system. Now, so it is going to be very, very common for you guys to have answers in here that are answers like 4 square roots of 2 and 7 pi minus a third. You're going to get these strange looking answers because they're completely legitimate values. We're not going to be married to just the integer values. So we're going to shade everything in there. Would that shading cover pi? Would it cover the square root of 11? But it wouldn't shade 3 pi because that would have been too far over. But then what do I have to do at 2? Because this says don't get there. We need an open circle. Now again, notationally, there are people from other cultures that don't do it that way. They don't do an open circle. They do this. So what I'm saying is that curved bracket is the same thing as an open circle. Cool? Now, what happens at 7? Closed circle, no big deal, right? And that's going to be in that other culture, they would choose to put a square bracket right there. So these are both really, really good. What do you guys think if you were typing your answers? What do you think of this one? Would this be easy for you to type? Show me how then. It's very, very difficult to type. I mean, it takes a whole bunch of steps. I do this all the time. Like you have to go into draw and make wide lines and little circles and fat circles. And it takes a while. Would this be easy to type? That would be a lot easier. However, you see that symbol? Is it on your keyboard? It's not on your keyboard. You actually have to go to an equation editor to get that symbol. So it's kind of good, but kind of bad too. So there's one more, and this is called interval notation. And this is my happy place. I love, love, love interval notation because the person that kind of coined this idea and went with it, it's so concise. It says start at 2, end at 7, done. So what am I trying to say? Is that all 4 of these representations, what do they say? Same stinking thing. So there will be times when I want you to answer this way. There will be times when I want you to answer this way. We want to be able to be proficient at all of the above. So here's what I want you to do. Number 2, I am going to give you the inequality version. Can you provide me with the other two? So there's my inequality. Can you guys go ahead and give me the graph and the interval? See how you're doing. Let's see what it looks like. Okay, so what kind of circle should I put at pi? An open? Or I could do the little curly thing, right? I like the open. How many of you guys learned the open versus closed? I learned the same way. I don't really like this notation as much. I like the open. And what do we want to do then? To which way? To the right, yeah. I want values that are bigger than pi, so we're going to go to the right. I'm a little cavalier about that. You don't have to shade. If you want to wiggle lines above, I'm good with that. It's pretty clear. So how the heck do you do this then? Because you have to do something to say where the story began and where it ended. So how are you going to do that? Where does the story begin from left to right? It starts at pi. Where does the story end? At infinity. Okay, which leads us to a question. What kind of symbol before the pi? We're going to go this way. And what about pi? Should I bracket that one or should I round it? Because this says, oh, I can go reach the number 7 and grab it, so I'm going to close it off. Can I close off infinity? Never, ever make a square bracket on an infinity because you can never reach that value, okay? Now, I'm going to do 2 more. So this occasionally happens, and I don't know if you can think of places in life where that happens, where an or comes into place. You know, you are allowed to come into this place if you know, like, let's say you can join if you're under 5 years old or if you're over, actually, there you go, I got it. You get a discount on your meal if you're under 5 years old or if you're over 55. Does that happen? Senior discounts, but they also have the little kid meals. You know, that kind of thing. So when I graph that one, I didn't want to write an X there. I would write this, and that's all good. And then I would write 19/5 with a circle like that, and I would go that way. So what is happening about that? Like I walk into Applebee's and I'm like, where's my discount? What are they going to say? Am I under 5? No, I'm not over 55. What are they going to say? You're not valid. You're not going to get it, but the people on the outside here do. Now, as far as interval notation, this is why I put this one in there. I don't know if you've ever seen this before, but what we do is we say that the story began at negative infinity. From left to right, you always do this from left to right. Truth begins at negative infinity until when? Till 3/4. At which point in time, there's a break. This is the symbol for union, which means an or. That's like, you could be in here or you could be there. It's this disjoint set. And then why did I put the square on that one? Because I can have it. And then what am I going to put next? Oh, positive infinity. There you go, which you don't have to write the positive. And then what should I put? Symbol square or round? Round, of course. Okay. You guys cool there? Just kind of an interesting thing. So the last one is one for you to do. So I'm going to provide you with a picture. And I'm being lazy. I gave you super nice numbers, just -1 and 7. And there's my picture. Can you write that as an inequality? And can you write that as an interval for me? You guys all right? And how you read that, by the way, is -1 is less than x is less than 7. So that implies that x is where? In between. It's stuck in the middle. So if you ever have that little block, like it looks like a line segment, you have to write it this way. By the way, I almost don't want to write it down because it pains me. If you ever see somebody do this, this is trash. If you ever see this, it's almost painful to write. You know, like somebody writes something like this or 2 and 6 and they go like, oh, I can't even do it. See how the alligators face the same direction? They have to do that. They can't ever go this way or this way. It's just not, it's mathematical gibberish. But what's kind of weird is what do I do for the interval? What do I do for that? Where does truth begin? As I go across left to right, where does it begin? And where does that story end for me? And what kind of symbols? Does that make you uncomfortable? Look at it. What does -1, 7 look like? That looks like a point on a graph. Is this a point on a graph? So we have the same notation for a very different idea, don't we? That's a really important thing. So just like your English class, it has to do with context. Just watch the context of the problem. If I'm saying find the domain, what range of values of x can I use? This would be a sensical thing to be a range, but if it says where do the two graphs intersect, well, that would be a point, wouldn't it? Where is this graph greater than that graph? This would make sense. You follow? So you just kind of have to, we know that the notation is the same for two totally different ideas, but it's not that big of a deal, okay? So I'm going to hit stop sharing on this, and I'm going to pause for a moment because I'm going to have you guys do some work for a little bit and just practice a few things, and then I'm going to bring you together. If I see questions popping up, I will address those questions that pop up. Like if it's a couple of times, I will address it as a group, okay? So do you actually know the distance formula? Do many of you know the distance formula off the top of your head? And that's been my experience, is we say, what's the distance between 2 points? And people go, oh, I got to look that up, because we don't remember it. So I have my own way of doing that. So let me show you how I deal with that. And then I'm going to help you be able to answer those questions in a very efficient way. So the distance formula is to find the distance between any 2 points. So I'm going to label my 2 points x2, y2, and x1, y1. And you need to understand that the distance from one to the other is the same as from the second to the first. It doesn't matter. Is 2 first or is 1 first? Doesn't matter at all. But the most convenient thing to do in that story is to turn it into a right triangle. You follow? So if I can turn it into a right triangle, then this coordinate right here at that right angle is very special. Anybody know what the name of that point is? How did I get to x2 as I went to the right x2, didn't I? Well, where is this point right here? Isn't it the same distance to the right as x2 was? So now what does that make this point? It's y1. It's the same height as that guy. So as it turns out, because this is a horizontal line, they have the same y value. So the only thing that dictates the distance from here to here is the distance between x1 and x2. So that makes this part right here x2 minus x1. And technically, as I talked to you a little bit ago, it should be in absolute values because I don't know which one's bigger and which one's smaller, okay? How about this one? What would this distance right here be? Notice they have the same x values. We're just going up and down. Oh, that's just y2 minus y1. Cool. Now, what could I do to find that distance then now that I've created a nice simple right triangle? Pythagorean theorem. I could say that a squared plus b squared equals what? C squared, which would be d squared, wouldn't it? Oh, but I don't want to do d squared. I want to do d, as that's the distance formula. But see, in math, that's just irritating. I hate that. Isn't that terrible? There's a better way. How far is it from 2 to 5? I mean, in math, we just call this change in x. How much did x change? How much did I move over when I went from one point to the other? This one would be delta y. So instead of writing it this way, I personally write it, how much did x change? How much did y change? I'm good to go. This is the bottom of the rectangle, the triangle. That's the side of the rectangle or the triangle. And then bam, we got it. Which means if I wanted to, I'm calling this number 5 going in line with what we did before. If I wanted to find the distance between these 2 points, it's literally this simple. Watch this, how slick this is. What happened to x, guys? What happened? It changed 3. What happened to y? It changed -2. That's the square root of 9 and 4 makes 13. I'm done. You see how fast that was? Now, somebody else would have looked at this problem differently and said, no, 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 no. From here to here, it moved 3. From here to here, it moved 2. Why can I ignore the pluses and minuses? Aren't I going to square it anyway? So does it matter? So with that in mind, can you tell me this one very quickly? I've got -2, 7, and I've got the coordinate 3, -1. How far are they apart? So let's figure it out. Write it down. See what you can come up with quickly without using a big obnoxious formula that you're going to screw up. All right, Christina, what happened to x? Oh, I'm sorry. Cameron, what happened to x? Huh. Olivia? Okay, cool. Can I just write 25 since we're going to square it anyway? Or Andrea, what happened to y? Very good. It changed by 8. A lot of people want to call that 6. That's the easy mistake, but you got it. It changed by 8. So what am I going to write down? You see how fast that is? I hate this formula because people get so locked up with the pluses and minuses and like trying to put the double negatives and all that stuff. Just look literally what happened to the number because you're making this picture in your head. You guys okay there? All right. So moving on a little bit further. Okay. So one of the things that you'll notice in what I've done for you is your first couple of worksheets are actually referencing the prerequisite section of your textbook. So if you look at my calendar, and some of you may want to have access to my calendar, hopefully this actually shows up and you can see this. I need to, let's see, stop sharing so she can see this better. I'm going to share this particular screen. I think this is the right one. Okay, we're right here. If you go to my calendar, let's see, go to here, I'll show you your class. So this is the one, and I want to display this one only. This is your class. So if you want a copy of that so you know kind of where we're headed and what we have assigned, we're sitting right here, and you'll notice it says prerequisites 1 and 2. Those are the 2 worksheets that I gave you. They actually refer to the first 4 sections of your textbook. So if you want to look something up and know where that is, that's in your textbook. And I've already posted your textbook right in here in Google Classroom. If you look right here, see your text prerequisites are sitting right there. If you open that up, your entire textbook is there. Chapter 1 is all there, chapter 2 is all there, and chapter 3 is all there. And that's actually all the entire semester for you guys. So you don't have to get a book if you don't want one. If you want to have access to this, if you want to go get one at the library, you can. But your entire textbook is sitting in Google Classroom right now as we speak, okay? So that's up to you. So there's just so many things to kind of remind everybody of. But I need to move on a little bit further. So this is actually coming out of P3, out of the textbook. So we're just going to do a couple of problems about solving. I'm not going to do much with this. This should be old hat stuff, but it's been a long summer, about a 5-month summer for many of us, since some of us didn't probably do anything for a period of time. We were probably supposed to do something, but maybe we did, maybe we didn't. I'm not going to throw any stones. But sometimes we study there's something buried in this problem that I'm worried about, and I'm not sure if you're going to catch what I'm worried about. Most students are going to look at that and see the fraction and be a little bit frightened. So what could we do to mitigate that? Oh no, there's fractions. What's that? We can break down the fractions. How? How do you get rid of fractions, everybody? Multiply by that common denominator. So when you look at this thing, what common denominator would you pick between all 3 of those things? I agree. So we're going to pick the number 40, and we're just going to hit every single piece of this with the number 40. And so this would cancel to leave an 8. So this front term, according to the distributive property, would be 8t and then what? Minus what? Yeah. I think I heard a mistake at the first, but you fixed it. Minus 56. Don't forget our friend, the distributive property. But the next piece is the reason I asked the question. What is the next chunk? What happens when I distribute this 10? I definitely have a 20t, and I definitely have a 30, but what kind? See that negative? Does that negative impact this? And that? That means those both must in fact be negative. That's really, really important. And then last, of course, we can pop that out and call this negative 35. Now, are we pretty good to go from that moment on a problem like that? Like, it was hard, now it's not. Are you guys okay there? Just a little bit of simplifying like terms here. But it does bear out that in this particular problem, I designed it to not be a real nice answer. Yes? The negative came in right here. You see that minus right there? The distributive property means that negative just pops through the whole top. Now, some people go, well, does it distribute to the top or the bottom? And I kind of say yes. You can either choose to put it on top or you can choose to put it on the bottom. You don't do both because then it would cancel itself out. But usually we distribute the negative to the numerator, okay? Now, in the same way, there is a second problem that I wanted to look at right here that I have noticed a lot of students coming out of Algebra 2 historically not know how to handle the solution to a compound inequality. Now, in this first problem, what we did is we used 40 to bust the fraction, right? So what would we use in that same way to bust this fraction? We'd use a 2. Now, this one had 2 sides. This one has 3. Which sides get the 2? All of them. So that means this side is a -10. This side is a 6. You with me so far? But if I hit it with a 2, what's going to happen to this part right here? It's just going to be 4x plus 7 because we entirely cut that out. And now, you know, if we went like this, what would you tell me to do? Wouldn't you say subtract the 7? So we're just going to subtract the 7. We're going to subtract that 7, and then we're going to divide by 4. It's no different than when you have those problems previously, okay? Now, all the 2 questions, that was my whole lesson on that, okay? So you're going to practice a little bit of that. This little negative right here worries me a little bit. When there's a compound inequality, I've seen a lot of errors in that in the past as well. And the last little topic of the day, and that's all the time I am going to have left, is about lines, okay? So do you guys, what was the first form of a line you guys learned how to correct? Y equals mx plus b, right? Love that. Do you guys remember what they called that? Because it has a name. Yeah, it's called the slope intercept form because you need the slope and the y-intercept. Good. So this is called the slope intercept, right? And that's a great form. It's developmentally fantastic because if you think about it, you start at B, like you put a dot on the screen, and then what does M tell you to do? Rise and run, right? You guys are probably love those. But this is not the only way to graph a line. Because it turns out there's another one out there that looks like this. And I don't know if you guys are familiar with that, but that's called the point slope form of a line. Have you guys seen that before? That's like this is my favorite. This is the best way. This is my happy place, okay? Love this one. Because all you need is a point. Well, didn't that need a point? And a slope? This needs a point and a slope. What's the difference between these two? Is this can pick what point? Any point. What does that one pick? Only the y-intercept, which is very limiting. This is far more broad, and this is called point slope. And why do we call it point slope? Because you need a point and a slope, and I don't care what it is. Now, last is, this is standard. I hate this one. I have to admit it. This is not my favorite. This is not my jam. I'm willing to go there, but it's not my favorite. It looks like this one, and they always capitalize. And there's a reason they do, but it's, do you guys know like this one? And what's different there? Notice that X and Y are on the same side. The number's off on its own, but there's something different that actually happens. These problems, everything is in the real number system. That capital R stands for real numbers, meaning you could have fraction, you could have weirdness. This one's weird. A, B, and C are integers. Now, do you guys know what I mean by integers? Can you guys give me an example of an integer? Say it loud. A whole number, 6. Could it be -2? Could it be 3/4? No, no fractions at all. Now the bummer is rise over run, what does that imply? Fractions. This doesn't have any fractions. So you lose context in this one, so it's not my favorite. There's one more little stipulation that the A value always has to be positive. I didn't make the rules, I'm just telling you what they are. If you do standard, there's no fractions, A has to be positive. Now what's the benefit of that if you're typing? Think about it. Do you guys like typing fractions? So if you type 2x minus 5y, would that be hard to type? Super easy. But if you were typing y equals 2/5 x minus 3/4, would that be hard to type? So engineers, people that apply math with computers often like standard form because it avoids that thing. So we have one question to do in the following way. And then I am done for today, and you will have a while to get this first set of assignments done, because I won't see you again until next Thursday. Oh, that's right. You're not. Just kidding. Monday. I was thinking this was fifth period because it's like in the afternoon. I'm back on the other schedule. Okay, so what we're going to do is find three forms. Okay, so let's talk about this. If I'm going to find those three forms, what's the first thing I need to know? What do you think the most significant part of any line is? Its slope. So again, this is amazing. That's my slope. We've seen that symbol before, haven't we? So tell me, what happened to y? It went up 2, didn't it? Didn't x go up 9? If you like this and you like tangling with all those dumb negatives, feel free, or you could just say what happened. It's quick. So let's write the first equation. Number 1, y minus 3 equals 2/9. Now, where did the y minus 3 come from? I get that one. So what's going to go in here? See, it's y, take away its y value. M, we found it. And then what should go in right here? The first time I saw a teacher do that, I'm like, wait a minute, you're cheating. You didn't do any work. Did I do any work? I just wrote down the answer. Is that valid? Okay. So let's go to points. Let's go to slope intercept. Is this good enough then? On my test, would I accept that answer? I already told you that's my happy place. I love that answer. The AP calculus test wants that answer. It's the best answer. So if we want to go the other way, we have to use the distributive property, which is not too bad. What's left to get it into slope intercept? Because I'm almost there after I distribute. What's left to get it to y equals mx plus b? I need to add 3 to both sides, right? Which, 3 is like 9ths, 27/9. I need to add 27/9 to both sides. So I know that a lot of you like slope intercepts. So you guys, I'm going to go to the point 5, 3, and then rise and run. You're going to go to 17/9, which is a jacked up weird number, and rise 2 and run 9. You like that? I don't know anybody who likes that. Okay, fine. Number 3, last but not least, how do I go to standard? What cannot be there? And have any fractions. So what are we going to do? Multiply by 9. So we got a 9y, we got a 2x, we got a 17. Are we close? What's wrong there? X is on the wrong side, so I got to move that. Almost there. Sorry, not my rules. You see what's wrong? The x component has to be positive. What's left? Multiply or divide everybody by a negative. Now, when you guys are working, what I would really, really like to see you become accustomed to doing, do you guys use Desmos ever? If you're shaking your head, no, change that. It's your friend. It really, really is. Let's see. I'm going to stop this share and split myself over to a different screen, which should be this one right here. Hopefully this works. But if you go the other way, and let's just go ahead and Desmos this thing. The beauty of it is if you go to Desmos and you're looking at this, you're preparing for a test, and you're like, I'm not sure if I'm doing this well. In Desmos, you can ask the question, -4, See the point? And you've got, now what was my goal in this problem? It was to find an equation that hit those two dots, right? So let's see if we did well on the first one. It was x minus 5. Oh, that's why I accidentally hit the caps lock. How did we do? You can see we nailed it, didn't we? But then I can come in and say, oh, well, let's try that last one. You know that I could do all three, but what about if I tried this last one? How long did it take me to validate that answer, especially knowing you're going to prepare for a test where you're going to have to do this? I promise you, the first test, you're going to have to be able to come up with equations of lines. By the way, that's why I said my class is actually easier than I normally do. I don't normally do this, but the college asked that question, so I'm like, that's your first easy little dinger for like people that like to play baseball, right? You're a baseball guy, right? That's a nice little soft pitch across the plate. You're going to get one of those questions. Can you find the slope between 2 points? If you can't, I'm really super sad. Yeah, and you're going to do some of those. So anyway, so your assignment right now is just to do those first 2 worksheets and upload them. So if you want to write directly on them and upload photographs, go for it. If you want to type directly on them and just save them yourself and upload them that way, you're golden. And thank you for listening attentively. And I won't see it for a few days, so I had to get a lot done. And if you want to, if you are an organized person and you want a copy of my calendar, let me know and I can share that with you. It may change here and there, but I can still share you what I have on tap, okay? And